So we have one last example in chapter 11, and then we're all done. Namely, we need to determine the sample size necessary for estimating the difference between two population proportions. Much like in chapter 10 and 9, you can't just go willy-nilly off and say, oh, I'm just going to sample people for forever. No, you have to figure out how many you're going to get. And there are two formulas for that. There's this one up here, which is saying, hey, I have some prior estimates to what the proportions are, like I did a sample in the past sometime. And down here, when I'd have no clue what the samples are, and then my best guess is 0.5 times z alpha over 2 over the error squared. Okay, so let's take a look here. Suppose a medical researcher wants to know if there's a significant difference in heart attack rates between those who take placebo each day and those who take aspirin each day. What sample size should be obtained if she wishes to be within 3 percentage points with 95% confidence, assuming that she uses an old study and has P1 and P2 hats be equal to those values. Okay, so for this one, she has an old study. So let me write out the formula. One sec. All right, there it is in all its glory. All right, so we have, oops, you know what? I made a slight mistake. This portion of it needs to be outside of the bracket. Good grief. There it is. Okay, now I know P1 hat and P2 hat because I have these old numbers for them. So let me write it out. So bracket, and instead of the P1 hat, I'm going to write 0.0179. Oh, one second. Poof, there we go. It's having issues. Let me just mention on a couple things here. I know that z alpha over 2 is 1.96 because we've calculated it so many darn times, but just in case you don't believe me, let me do a couple things here. Let me set up the spreadsheet. Hold on one second. There we go. Got them written in. And remember, the z alpha over 2 is going to be equal to norm dot inverse parentheses 0.025 comma 0 comma 1. There it is. All right. We've got all of our numbers all lined up. Everything's good. And then to find this number, we're going to have to follow this formula along. So let me do it down here. So n would be equal to bracket P1 hat. Oh, I know. Actually, I take it back. Parentheses. Sorry, forgot that. P1 hat times parentheses 1 minus P1 hat. I forgot that Excel doesn't like the bracket thing. All right. Then plus P2 hat times parentheses 1 minus P2 hat, close parentheses, then another set of parentheses, that's z divided by my error, which is 0.03, not 3, because it's the 3 percentage points, close parentheses, squared. Oops. Apparently I didn't finish off one of my parentheses. But there it all is. Oh, I didn't put my times in there. There we go. So we have to round up to 112. There's our final answer for that one. Okay, now how would it change for part B when you don't have a prior estimate? So when she has no prior estimate, oops, let me go type this answer. Hold on. There we go. Now, when we have no prior estimate, it means that it's going to simplify things a lot, because what happens is the formula just gets a 0.5 in front instead of all that other garbage. So the new n would be equal to 0.5 times parentheses that z divided by the error 0.03, not 3, squared, right? And we would round up to 2135. No matter how small that is, you round it up or you won't have the error you were looking for. All right, so 2135 is our answer. So let me go back here. 2135. Much simpler formula, much harder to actually go get that many people, right? So that's the danger. If you don't know a lot about past experience, then you're stuck having to go get a ton of sample. And we are all done with chapter 11. I hope you enjoyed it. See you, bye.